Hello, Twitch. I am A.M. Grabelny, a technical evangelist here at AWS. I'm joined by some gentlemen from the Amazon Aurora team. Would you guys please introduce yourselves?
Sure. I'm Yoav, product marketing for databases.
Great.
And I'm Kevin. I'm product manager for Aurora Postgres.
And I'm Steve. I'm a principal solutions architect.
Welcome. So we're going to talk in this session about managed databases, specifically Amazon Aurora. I'm going to throw out an impossible proposition here, okay? This is total fiction. Let's pretend I'm a developer who maybe doesn't care for infrastructure, maybe learned enough SQL to just be dangerous enough to, get around.
Right.
Or maybe I'm even guilty of only using OMRs, right? Object relational mappers. Is there anything in AWS for me, right? And again, this isn't impossible. This is me, right? I primarily have used ORMs in my career. I know SQL, I know database concepts, but really I've thrown it over the fence most times, I'm willing to admit. So what can I leverage from AWS to help me write database-driven applications faster?
Right. So, first of all, obviously there's many ways to run databases on AWS. You can spin up your own, virtual machine and run anything you want.
Right. My nightmare scenario is what you're saying.
Exactly.
Okay.
The easy way is to use a managed database service. So in a managed database service, which we call RDS, Amazon Relational Database Service, we run the database for you. You basically go to a console, or you go to, or through a script, or however you want to do it. You just start up a database, and then everything, like the hardware is provisioned for you. It does all the backups. It does all the patching. We don't know a lot of people who miss that stuff.
Yeah, I can't imagine that.
Yeah. So
I want to do more patching, please.
No, I don't think. No.
I worry about the OS. I'd love to touch the OS again.
Exactly.
Yeah, no, I doubt that. Okay.
Exactly. So we manage that for you. There's many types of databases that we support: relational, NoSQL, graph databases, analytics services, lots of different ones. What we're focusing on today is on SQL or relational databases. We're still a very, very big part of the development world.
Yeah, I've seen it go away, come back.
It's here.
They're legitimate use cases for a SQL-based database. Sure.
Absolutely, and we'll talk more specifically about Amazon Aurora, which is a database that we created at AWS, which gives you some benefits over other databases. So we offer several different databases, actually 6 different relational databases under RDS.
Sure.
Aurora is one that we created to be faster and to have higher availability and a few other advantages over other popular databases.
Right, and MySQL, Postgres, both open source, both solid databases, but I think a lot of enterprise customers have always trusted Oracle databases, SQL Server, because they've got enterprise backing, right? I feel like, from your description, maybe Aurora sits in that space too, that although it's fully compliant with 2 very popular open source databases, it also has the backing and availability of a more enterprise-focused database. Is that true?
Yeah, absolutely. And Kevin, maybe you want to talk about this a little bit, is that we made them compatible with MySQL and with Postgres, and you can choose which one you want, but with higher performance and some reliability and other features, and some features for developers, which of course we'll talk about in this session.
Yeah, I would love more of those.
And it's become a very popular migration target from the commercial databases that you mentioned, like Oracle and Microsoft SQL Server and DB2, and other more expensive, higher end, database people have been trusting for many years, but now they can get them at a lower price and be compatible with open source. So there's lots of migrations that are taking place.
Right, and really, that brings up a good point. There's really 2 cohorts or 2 groups of customers that are moving workloads into Aurora. One is the group that are moving from MySQL or Postgres, and they like the fact that Aurora is not emulating Postgres and MySQL. It's the Postgres open source code, the MySQL open source code, integrated at the lowest layers of the Aurora Storage. So it still has all the behavior of either MySQL or Postgres. So it just works just like those engines. Sure. So if we want to migrate from MySQL and Postgres into Aurora, MySQL, Aurora, Postgres, it all works the way you expect. Just faster with more durability, but functionally it's the same. Then the other cohort are customers moving from Oracle and SQL Server, from commercial databases, where they want the performance and scalability and high availability they're used to from those commercial engines, but they want it with the simplicity and lower cost of open source.
Well, and with the shift to things like .NET Core,
Yeah.
you see more and more customers looking to databases like MySQL and Postgres, right? Because it's now finally an option
Yeah.
for actually making C#-based apps again.
Yeah. It's opening up a bigger world for
Exactly.
developers, absolutely.
Sure.
One of the things we've done in Aurora initially, and we'll be adding this to other database engines later, is a tool called Performance Insights. And so I want to show a quick demo of
Yeah.
Performance Insights so
We
you
love
can see
demos.
what Performance Insights is for. And so Performance Insights is inside the AWS console. You go into RDS, the Relational Database Service section, and you can see in here, I'm going to go into database instances because we have some running instances here. And in this view right here, you see a bunch of different instances. One's running Oracle, we've got Aurora Postgres, Aurora MySQL, etc. This link right here, or this column, shows current activity, and you can see some of these links are actually links and not just text. When we drill down on one of these to see what's going on, that's when we get into Performance Insights. PI, or Performance Insights, is designed to show you the SQL statements that are running inside your database, sorted by how much load they're creating on the database. So you can very quickly see what the heck is creating all this load, and you can go back in time, like I can click here and say what was happening July 17th at 4:26. Well, gee, we had some obviously fake statements to create load,
Right.
but you get the point that, gee, I need to tune the select foo from bar statement, and maybe I need to add indexes, maybe I need to do something different. So, you can poke around with different time ranges, you can, go back longer periods of time. We, by default, will keep 7 days of single-second granularity data, but you can extend that to 1 or 2 years if you
Sure.
actually want to go back and say, what happened last quarter when I had a swarm of activity at the end of the quarter or whatever. So you get to drill down in all kinds of cool ways. You can even look at not the SQL statements, but which hosts are generating it, or which users. Now this isn't very interesting because it's all one user, but you could see, oh, that's the group that's messing up my database today. Let me go work with them to help them write better code
Absolutely.
or tune the schema or whatever.
It sounds like
Yeah.
there's still a rich set of tools on top of what's already there for most DBAs too.
Yeah.
I think a lot of the DBAs I've tortured in my career would really love looking at this dashboard.
Yeah, and if they're
see what
used
I've
to
done.
Postgres and MySQL, they know they have to run some queries and look at text data that they pull out of the database after turning on some logging, and it's hard to see what's going on.
Right.
And PI gives you this beautiful visual view right away. You can see what's
Yes.
going on. You don't have to do all that other those gymnastics. So.
And of course, let's point out that this is good both for the development phase and for production.
Right.
So for the software developer, like you're optimizing your SQL queries, you might use it during development, but the DBA or whoever is using it in production, like you could have a slow query in production, obviously could happen, and then you can use this for your production database as well.
Sure, and that's actually something that I've struggled with throughout my career, and I bet a lot of developers have. It's really difficult to get accurate data, right, for a dev and test
Yeah.
database. That's really hard to do. That's up to date and real production data. But I understand there's some tools here with Aurora that can help with that problem as well.
Yeah, so I'm going to hand it off to Steve.
Sure.
And let him show us all about fast database cloning.
Yeah, so I mean, much to your point, one of the big problems is getting developers the data they need so they can run accurate tests against their code and to make sure that they're dealing with what they're going to really deal with once that code hits production.
Right.
Normally that would entail creating a backup and having to copy that backup somewhere and restore it. It takes a long time, it requires a lot of resources, right? And it's something that makes a developer's life very difficult.
Sure.
So one of the things about Aurora that I personally love and that I think is oftentimes overlooked, honestly, is the unique storage system that underlies Aurora. Aurora actually, when we do writes, we actually are writing it to 6 different locations across 3 availability zones in a region. So we have 6 copies of that data, right? And it's a log-based storage that allows us to sort of rewind the tape or mark a specific place, in time for what the data looked like at a given time. And so that allows us to do things like create clones. And so let's say that, we're looking right here at our list of database instances, and so we have an Aurora MySQL instance right here, right? If we select this, and go to Instance Actions, we can scroll down here and just say Create Clone. When we say Create Clone, you can see that all of the settings of what the original cluster had are already preloaded, except, of course, we're going to need to specify a name here. So I'm just going to name this DB Clone, just because that's an easy name to use. And I'll scroll down, and for the time being, we'll just accept all of the other default parameters. And when we scroll to the bottom, we can say Create Clone. And so now you can see that our clone is creating. And I'll leave the screen up. It takes a few minutes to generate this clone, but I think what's important to note is we're not actually copying any data. Instead, what we're doing is that storage layer that we were talking about, we're marking the point in time that I said create this clone.
Right.
And from this point forward, on the same storage nodes, for the original cluster, there will be one chain of changes, and on the clone, there will be a different chain. So this means that regardless of how large our data volume is, whether it's 1 gigabyte or 50 terabytes, it takes just a couple of minutes to create this exact copy, this exact replica of the original cluster, so that you can use that for your development purposes,
Right.
and a host of other purposes too.
In local development, that's sometimes not even possible, right?
Right, exactly.
To pull down that amount of data. So to me, it sounds like you can spend more time. I know I've done this. I've written tests that are unreliable because the proper data isn't being hydrated from
Right.
the database. But I feel like this would give me more reliability. This would help me write better tests, and then I could focus on new features, new things in my code instead of worrying about, did I get the right data?
Right, and there's that aspect of building an application, trying to test out new things. But then after you deploy it, if something goes kind of funny in production, what you can do is clone the database right there.
Right.
Let production keep rolling forward, because it has to, it's live, but then you can go figure out what's going on by taking that clone
Yeah.
right away. And see what's messed up in the data, what part of your code did the wrong thing, something like that.
I've dropped days
Yeah,
on
right.
a weird value in a database
Right,
before,
right.
for sure, absolutely.
But what I like best about what I like best about it is that the development and test process becomes much more flexible and kind of generous, so to speak. Like you can tell your QA team, go clone as many copies as you want. Every person has their own database copy. They can do whatever
Right.
they want with it. It's not, it's a storage is expensive and all kinds of problems like that.
Yeah, I've heard the term bandied around a lot. Oh, we'll have a sandbox environment, and it's never a sandbox environment. It's some amalgamation of production that really isn't production. So yeah, that's really exciting.
Another thing that's nice about the clone too, and AWS in general, is the programmability of it. So as a developer, it's very easy to program, say, the creation of new clones on a daily basis. So you could, say, schedule a task that once a day will create a fresh clone for you, so it's ready to go first thing when you come in the morning. There's no additional cost to
Sure.
it.
That's a
We've
key
got a
point.
question, actually, real quick.
Okay, go ahead. Yeah.
Twitch asks, what about performance in clone DB instances?
Yeah.
Can you speak to that?
So with Aurora, I talked a little bit, and I could go on and oftentimes do, about the details of that storage engine, but suffice it to say that we have literally hundreds or thousands of storage nodes that underpin that storage volume you're talking about. And Aurora is intelligent enough to know which of those storage nodes are performing the best and which ones are not. And so it will make sure that it will use the highest performing storage instances to drive that throughput. So even if you create a clone and you write some wild, crazy queries that you think are consuming everything,
right.
you're hitting a pool of literally thousands of storage nodes. So there is no appreciable impact at all.
In other words, it's good for performance testing, not just for functional testing.
That's exactly right. There's no impact on the original cluster, regardless of what you do on the clone.
Okay, fair enough, great. Sorry, cut you off.
Yeah, and I'm trying to remember what I was going to say, so it'll come back to me.
I know. So we have another question. Could you sum up one more time the difference between this and Oracle SQL and MySQL, for example?
So this meaning Aurora versus Oracle and
Right.
MySQL.
Right.
So Yeah, we can go back to kind of the origins of Aurora. It was all about customers asking us to give them the combination of Oracle capabilities, or SQL Server, and open source capabilities. That caused us to rethink the whole architecture of relational databases and rebuild the storage layer at the bottom.
Right.
The storage and logging layer, we like to say we reinvented it for the cloud and built a cloud native storage system, and that's what Aurora Storage is. And so the difference is that Aurora Storage and Aurora itself is native to the cloud. It's not a 30-year-old architecture that was built for on-premises and has slowly been growing,
Exactly.
but still a silo. It's,
Sure.
it's built, integrated in with everything else in AWS, and including RDS.
Right.
The relational database service capabilities you all have talked about, so you get all the automation benefits, all the stuff that is boring and deadly for DBAs to do over and over again, we automate that.
Right.
That's part of Aurora as well. So at the same time, it's still got MySQL and Postgres on the top, so it's still compatible with stuff that customers are used to, that developers are used to.
Yeah, two phrases I've heard that nobody wants to tangle with: fault tolerance and high availability.
Right.
These are both, helped out, managed through Aurora, through replication and availability zones, much like we see in a lot of managed services in AWS. Is that a good summary too?
Yeah, it's just automatic and built in.
Right.
Aurora gives you 6-copy, 3 AZ durability, transparently, automatically, always there. And if you want to do that in Oracle or MySQL or Postgres, you have to do a lot of manual work and a lot of gymnastics to keep it up and running if you want to roll your own.
Right.
And as a developer, you don't want to think about any of that. You just want a thing to
Right.
work, right?
Not to mention if you want to spread it geographically to multiple regions,
Right.
that's a lot of work if it's
Right.
not in the cloud and if it's not a managed service.
Absolutely.
Yeah.
Yeah. So we're running close up on time.
Yeah.
We've got about 2 minutes left. Are there any other details or developer-centric things that you all would like to share about Aurora and why, as a developer, it makes my life easier?
So I think one of the things that was touched on earlier, and I think it bears repeating, is that we are wire compatible with MySQL and Postgres. And what this means to a developer is you don't have to learn a new set of APIs. You don't have to learn a new language. If you have an application that today runs in MySQL or runs in Postgres, if you move the data and then change your connection string, it will just work.
Right.
And so that lowers the bar considerably for migrations. It lowers the bar considerably for what you have to learn to move into Aurora.
Yeah, in the case of something like Entity Framework, you just pull in a library for Postgres, and
right.
it doesn't matter that it's Aurora behind the scenes.
That's right.
That's great, yeah. So, just to kind of summarize, it sounds like a lot of the heavy lifting, a lot of the monitoring and checking in on what's going on in your database really is lifted up from you, so that, again, you're storing all of this data. Maybe you can start to focus on, what do I do with this data? What can this data do to push my business forward, to come up with new features, new use cases that delight my customers, instead of worrying about,
Yes, and
is your data...
You'll see we'll continue to automate more and more of that boring stuff.
Right.
That is important but boring.
Automate the boring stuff, that's...
Another thing too,
So,
just real quick, that I think is important for developers is developers come in all different sizes, right? You have giant enterprises, you have very tiny startups.
Yeah.
And so the enterprise features of Aurora, for example, that storage layer we're talking about, it is with every single Aurora cluster. So whether you're a tiny little startup or a huge enterprise, you get all of those features.
Great words to part on. So I want to thank you guys for joining me. And
Thank you,
Twitch will be right back in about 5 minutes. Come back and see us.